Hello everyone and welcome to this presentation where we're looking forward to showing you our Boeing 767 aircraft. My name is Captain Dave Henry, Flight Operations Director, Leisure International Airways. We are responsible for operating this aircraft for our in-house tour operator Unijet, taking their holiday passengers to many tremendous destinations overseas, long distance, such as America and the Caribbean. We visit islands such as Jamaica, Barbados and Cuba. Today we'll be flying from here at London Gatwick, where I have to say the weather is pretty miserable, hopefully to the sunshine of Florida, specifically Orlando. So if you'd like to join me now, the first stage of the preparation for the flight will be down a small room in the basement of the terminal, where we'll meet up with my colleague who will be joining me on the flight, and we will start preparing for that flight, going through all the preparation of our navigation log, fuel plans and weather checks. Welcome to the briefing room. It's obviously not the Ritz, but it's nice and quiet here, and this is where we can prepare for our flight. Before we get into that, most importantly, let me introduce you to Norman Port, who's going to fly with me and help me across with everything that's necessary. In fact, what we do, we nominate quite carefully who is the flying pilot, who is the non-flying pilot, and there are specific duties for each pilot. And indeed, even at the preparation stage, the work that we do is equally distributed, but then we check each other's work for safety's sake. The preparation is probably, in my view, the most important part of the flight. The flying bit's pretty straightforward. This is the place where you make the very vital decisions. But all the data we need is here, and from this data we can really carefully work out our plan for the flight. So we can see from this today that we are the Leisure 705 in aircraft Golf Uniform Kilo Lima Hotel, departing from here Gatwick to Orlando, and we're using as an alternate Tampa. The fuel plan shows me that our flight time is going to be just under 8.5 hours, and we're going to burn 42.5 tons of fuel. But as we wish to carry our safety fuels on top of that, we'll actually be loading on the aeroplane approximately 50 tons of fuel. Moving on down the data, we have everything we need for our diversion information. We have the complete nav log of the route, and in fact Norman right now is plotting that route across the Atlantic onto the plotting chart. We have our flight plan, and then we have all the weather, both aerial weathers and specific weathers for the various airfields that interest us during the flight. Also, notices to airmen. If there's anything specifically unserviceable, construction or anything like that happening at an airfield, we have a note of it. We already have available the loading information for the flight, and for your interest we have 334 passengers on board. We have nearly 3 tons of freight and something like 8 tons of baggage for our passengers. Therefore, we're anticipating a takeoff weight of just over 172 tons, which is over 10 tons below our maximum takeoff weight, so we have a little flexibility. And we're anticipating burning, as I said earlier, over 42 tons of fuel, so we'll be landing in Orlando at just around 130 tons. The aircraft is being loaded carefully, in other words, the baggage and the freight is being balanced, and we actually have details here of the balance of the aircraft, which is well within limits. The next thing we'll do then is actually work out the performance that we need today for a safe departure from Gatwick. What we have to be absolutely certain of is that during the takeoff, should we at the most critical point, that is the moment of rotation, lose an engine, we still have enough power and energy available to climb away safely and clear the obstacles on that departure route by a designated margin. Not only can we do that with this weight of takeoff, we can actually reduce the thrust of the engines just a little and still achieve all those parameters And of course we are eager to do that. It's far better to run your engines a little bit off maximum power, to look after them, to conserve them. And from all this information, we've been able to construct our takeoff bug card, which gives us all the details we need for a safe takeoff from Gatwick and climb out, even in the unlikely event of an engine failure. We have just a little bit more work to do. Mainly, I'll be checking what Norman's doing now. He'll be checking all my decisions on the fueling figures and generally preparing ourselves. And as soon as we've completed that, we'll be out to the aeroplane, inspecting it and preparing it. And I suggest we meet you on the aeroplane in a few minutes. Done all our preparation in the crew room, and now we've put all that preparation into the aeroplane itself. We've got the computer fully programmed for the flight ahead of us, so we're ready, and my next step is to fully brief Norman so he knows precisely what we're going to do during the takeoff phase. Okay Norman, let's brief for our departure from Gatwick. We're on stand 21. So push back, normal way, tail going to my left, taxi out, runway 26 left, absolutely standard procedures throughout. Takeoff then, absolutely standard operating procedures. See anything wrong before 80 knots, let me know. After 80 knots, if I feel anything wrong, I'll stop the aircraft, follow me through, tell air traffic, and we'll take the appropriate action when we have time to do so. Okay, if we have a failure at V1 or after, we'll get the aircraft into the air. Remember and remind me, there is an emergency turn, 15 degrees to the left. We'll climb out on that heading. Again, tell air traffic when you can. Just cancel any warnings we might have. Otherwise, just watch the flying, make sure everything's kept safely away from the ground. Any recall actions I'll call for, any emergency actions I'll call for. Okay, make sure we point out every control before it's changed, and we'll climb out to the west, assess the situation, There's no hurry to land. We've got plenty of time to actually get rid of the fuel from the center tank, to lower down the weight, then we'll return to Gatwick as necessary. Hopefully everything goes normally, so we'll be looking for a Lamborn Departure off runway 26, which is plate Golf 1, 3rd of February 1994. Transition altitude is 6,000 feet. And the departure itself is straight ahead from the runway to a DME of 2.3 off the ILS, a right turn to establish inbound on the 081 to Detling, climbing to 3,000 feet, and then at Detling 10 DME, left turn to establish 341 into Lamborn, climbing through 5,000 to 6,000 feet. As far as the aircraft's concerned, the ILS is ready on the ILS box. Left VOR is set up for that 081 radial into Detling, and the right hand VOR is set on the 341 inbound to Lamborn. The height 3,000 feet is set, and the only final thing to brief then is safety height will take 2,300 feet throughout.
Roger.
Any questions?
All understood.
Okay, fine. Brakes are off, sir. We're moving 1142.
Sure.
Ready to start the right engine, sir? Thank you. Okay for the right. Starting? Okay, starting now. Okay, light up is good. Spooling up normally. Okay, monitor the right engine for me. Round, like to start the left engine, please. Thank you. Recall, we know about that. Cancel, starting the left.
Right engine, please.
Thank you. Okay, fuel on. Light up on that engine. Okay, so we got two good starts. See you on the left. Cheers now.
APU.
APU's off.
Engine anti-ice.
Not required off.
Left and right isolation switches.
They're coming off.
Recall.
Checked.
And ground equipment.
See him on the left. Thumbs up.
Right.
Taxi clearance, please.
Leisure 705 is ready for taxi.
Leisure 705, ready to take taxiways 3 and 5, holding point Alpha South, QNH 9097.
35 Alpha South 9097, Leisure 705.
Okay. So, confirming 3 to the first left, Alpha South. Yep. Okay, flaps to 5, please. And rudder check if you're ready.
Roger.
Going full left,
Check.
going neutral,
Check.
and going full right. And neutral. And the tops, please.
Yeah, and the top. And the tops are good.
Thank you. Okay, takeoff briefing review. Event of a problem on takeoff, remember it's 15 degrees left for the turn. Otherwise the performance still good.
705, hold Alpha South please, contact the tower 12422, bye.
Alpha South and Tower 12422, leisure 705. Good day. Tower, good morning, leisure 705 with you for Alpha South.
Leisure 705, hello, hold at Alpha South.
Hold Alpha South.
And the departure's the Lamborn as briefed, if you're still happy with that. Okay. Before takeoff checklist, please.
Before takeoff.
Thanks.
Flaps.
5.
Flight controls.
Checked.
Packs.
On.
Auto brakes.
RTO.
Takeoff briefing.
Reviewed.
And cabin.
Secure.
Before takeoff checklist.
Thank you.
Leisure 705, line up and wait on 26 left.
Line up and wait, runway 26 left, leisure 705.
Secure the cabin, yes please.
Will do.
Leisure 705, clear takeoff 26 left, 30015 knots.
Clear takeoff 26 left, leisure 705.
Stabilised. N1. Thrust is set.
Thank you.
80 knots. Throttle hold.
Checked.
V1. Rotate.
Positive rate, gear up.
Positive right, check, gear up.
LNAV, please.
LNAV.
Flight level change at plus 40.
Flight
The
level
speed,
change,
please.
plus 40, we're right there. Flight level change speed.
Right.
Leisure 705, contact London Control now, 120.52, bye-bye.
12052, good day, sir.
And just watch the outside air temperature
Yeah,
for me,
11 at the
please.
moment.
London leisure 705 is with you, departing 2,200 feet, about to turn right.
Leisure 705, good afternoon. Squawk ident, climb 6,000 feet, no speed.
Ident 6,000 feet, no speed, leisure 705.
6,000 set.
Is seen.
Central to pilot in
Check.
use.
It's still 12 out there, aren't it? So
That's fine,
too
thank
bad.
you. Go heading select for a moment to bring it round the corner.
Leisure 705, climb flight level 110.
Climb flight level 110, leisure 705.
110
Is seen.
set. Flaps 1, please.
speed checks, flaps 1.
Okay, approaching transition,
Check.
10:30.
Roger. 10:30.
Temperature 10, Norman.
Roger. Speed
Flaps
checks.
up, please.
Flaps up.
Crossing 70 now.
Check.
After takeoff checklist, please.
And the after takeoff checklist. Landing gear,
Up and off.
flaps,
They're up.
and altimeters.
Set.
After takeoff checklist complete.
Thank you. Okay, swapping to VNAV.
Roger. N1 VNAV speed.
Jet.
It's +9 out there at the moment now, Dave.
Yes, engine anti-ice on, please.
Both on.
Thank you.
Leisure 705, climb to flight level 130 and turn left now heading 340.
Climb 130, left turn, heading 340, Leisure 705.
13 340.
Thank
And
you.
heading select.
Through 10,000 feet.
Roger.
Cabin can start working, please, Norman. Thank you.
Okay for the bottom screen to go?
Yep, fine, thank you. As you can see, we're only 10 minutes into the flight and
Leisure
already
705, climb
things
flight
are
level 280.
calming
Climb
down.
flight level 280, Leisure
We've cleared up
705.
to 28,000 feet. And we're presently just over North London, I guess, at the moment.
Okay. I'll try and get the clearance.
Okay.
Off the air.
Good afternoon, Leisure 705 for the Oceanic.
Leisure 705, good afternoon, sir, go ahead.
Leisure 705, estimating 56 north, 10 west at 1300. Request flight level 310, Mac decimal 80.
Leisure 705, climb down to flight level 330.
Thank you. Reclear 330-705. Reclear 330, Norman.
Okay, Roger.
Leisure 705, show me your clearance.
Leisure 705, go ahead with the clearance.
Leisure 705, be advised, sir, you have a track change. Tronic clears you to Orlando, now on track Charlie, from 57 north, 10 west, maintain flight level 310, mark decimal 80.
That GC clears Leisure 705 to Orlando. Now track Charlie, that's 57 north, 10 west, 58 north, 20 west, 58 north, 30 west, 58 north, 40 west, 57 north, 50 west. Loach Fox from 10 west, flight level 310, Mac decimal 80.
Leisure 705, that's all correct, sir. And could I have an estimate for 57 at 10 when you have one, please?
Stand by.
1303.
1303, check.
Yeah.
And Shamrock Leisure 705, estimating 57 north, 10 west, 1303.
Leisure 705, thank you, sir. You can now continue with domestic. Goodbye.
With the domestic, thanks a lot, bye-bye.
Back with you at long last.
Okay. Okay, I've got time to chat with you again. We've been able now just over an hour and a half, and everything's nice and settled down in the cruise, presently at 31,000 feet. And I'll take the opportunity to just give you a quick guided tour of the flight deck, what we've got in front of us. Let's start in front of me. Primary instruments we have the ADI and below it the HSI. ADI gives all the information you would expect from a normal artificial horizon, and the HSI, horizontal situation indicator, can be changed to a more conventional mode, which you might see on a conventional aeroplane or a light aeroplane, but being a cathode ray screen, we can actually put a lot more information onto it. And the mode that we're using to cruise along with is this map mode. We are the triangle, and the reddish line or magenta line is in fact the track that's taking us across the Atlantic. The next point which we need to confirm with air traffic control is displayed, and then around the screen a lot of other information. The distance, 52 miles, and the arrival time at that waypoint, and in the bottom left hand corner the actual wind that we're experiencing at the moment. Let's move on now to the next set of instruments in the center, which are the engine instruments. On the top screen, which is displayed at the moment, we have our primary engine instruments, and then in the lower screen, which I'll switch on now, we have the secondary instruments. So let's look at these instruments in a little more detail. Top screen, as I said, the primary instruments. We've got the N1 readings, which are the actual speed of the fan at the front of the engine, and it's the speed of that we use to know the actual power coming out of the engine. Below it, the EGT, exhaust gas temperature, the temperature of the engine, and those really are vital instruments for us. Top one, power, and the lower one of the two, the actual state of the engine, and we leave those on all the time. The lower screen, secondary instruments, just showing you quickly, we have the speed of the actual jet engine, the fuel flow, and at the moment you can see the fuel flow, 2.6 tons of fuel per engine per hour. Picking it up on the left-hand side, we have the oil pressure, oil temperature, oil quantity, and the vibration for the two engines. The important thing to note on the lower screen is that we will normally have that switched off during the cruise phase, because if any of those parameters go out of limits, the screen automatically comes on, highlights the parameter that's out of limit, and we can immediately take action to cope with that situation. Let's move up to our main control panel, mode control panel, which is really the main link in flying the aircraft, either automatically or manually. It is the link between the computer through the different modes to the autopilot, or the computer through those modes to the flight directors for the pilots if they're flying the aircraft manually. To explain from left to right, on the left side we've got modes that allow us to move the aeroplane dynamically, if you will. I don't quite understand what that means, but I think it means speed and height. And we can either take sub-modes, or the main mode here would be from VNAV, which is the actual computer operating the vertical speed, the height, and everything controlling the aircraft dynamically. Moving across one stage further, we come into more of the lateral modes, the heading mode or the LNAV mode. LNAV mode is when the computer is giving all the information about the navigation again to the autopilots, or the heading select, just simply setting the heading you wish to fly and following it either with the autopilot or the flight director. Moving on again, we come to our vertical speed window. If we wish to make a descent and modify the rate of descent, we can do it with vertical speed by selecting it and then actually turning the wheel up or down as required to the amount of descent or climb that's required. Coming across again, our actual altitude selections, and obviously at the moment cruising at 31,000 feet, that is what is indicated. The instrument landing system, and I hope we may be able to demonstrate some of this during our arrival into Orlando. Finally then we come to the 3 autopilots. As you can see, just the central autopilot is illuminated. In the cruise, 1 autopilot is used. When we start descending into an automatic approach, then once we select the approach mode and descend, quite automatically all 3 autopilots will come online, and the aircraft will then be controlled by all of them, because obviously for an instrument approach everything must be done very, very precisely, hence the need for all 3 autopilots to be online. So what I've done is taken you through the instruments and controls that I'm looking at as the pilot flying, and what I'd like to do now is hand over to Norman and let him take you through the navigational, the radio and the actual systems of the aeroplane that he's monitoring as the pilot not flying on this flight.
Okay, well I'll take you through the system panel, which largely replaces the traditional flight engineer. Starting with the inertial reference system, 3 independent laser gyros, which gives us our position throughout the flight, and our sole means of navigation across the Atlantic. Moving down, we have the 3 separate hydraulic systems, left, centre and right. Up here, one of the high frequency radios, and moving down a little bit further, the electrical system. Moving up once again, we have the emergency lights, passenger oxygen, and the engine start and ignition system. Here we've got the fuel jettison, and here we have the different fuel systems. A little bit further down we have the anti-ice systems, the wing anti-ice and the engine anti-ice. Windscreen wipers, which we sometimes need if it's raining. We've also got the rain repellent system, which squirts a liquid onto the windscreen, and it's very effective in clearing the windscreen of any water. We very rarely need to use that, but it is very good if we have to use it. Here we've got all the anti-collision lights for the aircraft, position lights at night, the red flashing beacon, the white strobes, and the wing lights if we need them, and all the landing lights below those. Up here we've got the window heating system and the cargo heating system, another HF radio, and various call buttons throughout the cabin. Cabin crew can call us. We've also got the cell call system here. As we're over at the Atlantic and we're using HF radio, the radio operator on the ground can feed in our code into the system, and we get an alert signal and a light appearing up here. Here we've got the pressurization system, all set for Orlando, which is 100 feet above sea level, and all the indications that we require for the system. A few more lighting switches, and up here we have the cabin temperature. But normally we try and set that for about 24 degrees throughout the cabin. We've got 3 separate zones for that. And moving down from the cabin temperature controls, we've moved down to the air conditioning system, which supplies conditioned air to the cabin and also pressurizes the cabin. and hopefully that's shown you through the systems panel for the Boeing 767. Okay, moving a little further down, we have the main gear lever, the flap indication, and below that we have the alternate flap and gear extension systems. Here we have the two flight management computers, the engine thrust levers including the reverse thrust, the flap lever and the speed brake. Down here we also have the alternate stabilizer trim if we need it, and either side of the thrust levers we have the stabilizer trim indicators. Here we have the fuel control switches for the left and right engine, the two engine fire switches, the APU fire switch and the cargo hold fire suppression system. Below those we have the communication systems, and we can select which VHF radio we need, which HF radio that we need. The transponder including the TCAS system, which we will try and explain a little bit later on. And below those we have the rudder trim and the aileron trim and the test systems for the engine fire and wheel well fire and cargo fire systems.
Okay, what Norman's done is gone through quite a technical description of the aeroplane. But what a lot of people ask us when they visit and talk to us is, what's it like to fly? And it's actually an incredibly nice aeroplane to fly. It's a large aeroplane, yet it's responsive. Obviously there's a lot of engine power from the two engines that we've got. The most difficult aspect of an aircraft like this is if one engine is lost. And this is something that we practice continually in the simulator. And yes, that takes a little bit of getting used to, but once you've achieved a certain standard, you can fly away simulating losing an engine just at the worst possible moment of takeoff and control the aircraft really quite smoothly and quite accurately. For the rest of the time, as I say, large aeroplane, a lot of controls, and yet quite simple to manage, quite simple to understand, and indeed quite a nice aeroplane to take into airfields that perhaps haven't got all the aids that you would wish. The weather's not particularly good. You can feel quite comfortable with it. Two-man operation often brings comments. There certainly is a distinct workload levels at times that are high, but as long as the team work together, there's really no problem. And this is why our airline, other airlines, work with very clear procedures of what we're going to do. So each member of the crew knows precisely at any time what his particular responsibilities are, and also to monitor the other guy, make sure he's doing his job properly and the aircraft is really performing as is required. If I look now, I can see that we're just over halfway across the Atlantic, and I think maybe it's a time just to say a few words about Atlantic airspace. This airspace is quite unique, in my knowledge, worldwide. It doesn't have the normal airway systems that we are used to over continents. And the reason for this is that the traffic across the Atlantic varies by day and night. By day, the majority of the traffic is doing what we're doing, moving from Europe towards the United States. The reverse applies at night. Also, the other major factor that is considered, very, very strong winds that can blow across the Atlantic, normally from west to east, that's to say, against us on a flight such as this. So, North Atlantic tracks are established each day in the morning in the UK, and because the wind will normally be strong against us, they'll move the tracks to try and avoid them as best they can. At night, tracks are organised by the Canadians, but obviously in this situation we want to take advantage of that wind to blow us back to Europe as quickly as possible. Particular flight today, we've moved quite a little bit north. We've actually left Gatwick and moved way up by Manchester, the Isle of Man. This is to get north of quite a strong jet stream that's blowing across the middle of the Atlantic. The actual tracks today, we actually picked track Delta, a mid-track, and because of the congestion and the amount of traffic wanting to enter those tracks at the time we wanted to, air traffic couldn't actually give us the track we required. And they've moved us to a parallel track 60 miles north, track Charlie. We had that plotted. We revised all our tracks and distances, which has kept Norman pretty busy, and he's happy about that. And now we're following that track. We're reporting back initially to Shannon. Now, because we've moved more than half the way across the Atlantic, we're talking to the Canadians at Gander, and we'll continue to do that on HF until we reach the Canadian border. So, the Atlantic, quite a unique bit of airspace, as I say, very closely controlled, obviously procedurally. In other words, there's no radar out here, so we follow almost a railway line system, entering a block, exiting a block, reporting that we've done that before another aircraft will be allowed into the block. The tracks themselves are some 60 miles apart, and they have various heights. We're at the lowest level today, 31,000 feet. Sometimes, particularly at night, it's quite good fun in seeing other aircraft. We are flying a 0.8 mark or 8 miles a minute. The jumbos fly a little bit faster, so sometimes we can see them overtaking us as we cross between the United States and the UK. So that's the Atlantic. As I say, quite different from anything else that we experience. So we're just coming towards 50 degrees west, which means that we're just somewhere south of Greenland at this time, so well on our way. I spent a bit of time explaining the aircraft to you and how the Atlantic is set up, but one of the things that we really haven't mentioned in any detail is the fact that we're flying across these long expanses of water on a twin-engine aeroplane. And this is something that has, over the years, developed new techniques and procedures that we must follow that are not necessarily followed by the multi-engine aeroplane. Obviously, if we were to have an emergency, we have to react in the normal way. But let me first of all say that any normal twin-engine operation, the aircraft must stay within 1 hour of an airfield that it could divert to. Obviously, we can't do that on these long-range flights. We want to be much further away from those airfields. So we have to abide by rules called Etops Rules, and they're the rules governing the extended range of twin-engine aeroplanes. And there's a lot of factors that go into that. The build of the aeroplane, the fact that this is an extended range version of the aircraft, the fact that it's got extra equipment, which Norman highlighted a little while ago, the fact that we have, for instance, 4 electrical generators on the aircraft, 1 on each engine, 1 on the auxiliary power unit, and yet a 4th one in the hydraulic systems. All other systems have these tremendous amount of redundancy in them, which hopefully we will not see. So that's the aircraft. The engines, they must be proven over many, many hours, and all the world fleets of types of aircraft, in this case the 767, must report those hours back to the manufacturer and to the different authorities. Only then is the aircraft cleared for long-range operations. Then it comes to the actual airline. And for us in leisure, we had to spend a number of months when we were not allowed to operate the aircraft more than 60 minutes away from an airfield. But we developed our procedures, we proved our procedures to the Civil Aviation Authority, and eventually we moved from 1 hour away from an airfield to 2 hours away, and at present we're sitting at 138 minutes away from a suitable airfield. Sounds a peculiar number, but it is explained that in the Atlantic, if you are 2 hours away from a suitable airfield, there is actually a hole in the Atlantic through which you cannot fly. By getting the further extension of our clearance to this 138 minutes, we in fact can cross the Atlantic on any track that is available on the day in question. However, during our preparation earlier today, we spent a lot of time checking that we fulfilled all the requirements of these rules and regulations. And obviously during the flight, we're continually monitoring that. The thing that we tend to use most of all is our plotting chart for the Atlantic. On that, we can monitor the accuracy of our flying and also keep ourselves absolutely abreast of where we are, our relative position to our nominated airfields. And if I can, let me just take you back to that chart and just have a look how we're doing. Don't laugh, I need my reading glasses to help with this one. Okay, we plotted before we left the briefing room today the track across the Atlantic that we were hoping to fly. As we've already mentioned, because of the amount of traffic on the Atlantic, air traffic has moved us up to this Charlie track. Every time we pass a reporting point, we turn onto our new track for the next leg, and then we do a fix to confirm that the aircraft is indeed following the track that we require. The other thing that we use the chart for is to be absolutely certain that we are within legal range of our diversion airfields. And on this flight, our diversion airfields that we've nominated are Shannon in Ireland, Keflavik in Iceland, and St John's in Newfoundland. And these little radii all over this chart allow us a quick check to make sure that we are always within the 138-minute rule that I've just spoken about from each of these airfields in turn. The other thing that we plot on the chart are the equidistance points. This is the equidistant point for our track, equidistance that is from Shannon and Keflavik. And so very much we keep ourselves mindful of where we are. And so leading up to this point, we are mindful that our diversion, should we need it, is back at Shannon. The moment we pass that point, we change and we're thinking Keflavik. We continue along our track, and once we pass the second equal time point, we then change from using Keflavik to St John's itself. And this is just good airmanship. It's not clever in an Etops operation. It is something that I would think all pilots do, regardless of the size of aircraft or where they're flying. For us, over these long expanses of water, we're very careful about this. Why are we very careful? We're very careful because if we are flying a track, there are aircraft around us. If we have an emergency, if we have to divert, we have to do so most carefully. Most people would think that the worst emergency we could experience would be the loss of an engine. And in some ways that is true. But in pure fuel burn terms, it is not the worst. The worst is the loss of pressurization. Because if we lose pressurization, we will need to descend very quickly to something like 10,000 feet and then head for our diversion airfield, let's say in this case Keflavik, on 2 engines at low level. And that, I can assure you, is going to burn one hell of a lot more fuel than the case of losing an engine, being able to drift gently down to a suitable height on single engine. So, Another of our very careful checks when we're making long tracks like this is what we know as the critical fuel. The critical fuel in the 767 is always the pressurization failure case. If one loses an engine, let's go back to that in a track, the actual procedure is not difficult, but there's a lot to it. And we in Leisure have given a great deal of thought to this. If I just put that down for a minute and bring up a book that we've devised within the airline, I hope it can show to you how we've really thought about these various procedures and how we do whatever we can to the crew in the air to help them if there is such an emergency. If I can just flick through the book just to give you an example of its content. First of all, we've got all the various airfields across the Atlantic that we might use as diversion fields. We've actually got little maps highlighting where they are and the frequency associated with their weather broadcasts. So that's the Canadian map, the East Coast of America map, the Caribbean map, and then just a general map of the Atlantic. We also give to our crews all the various radio frequencies and procedures that are necessary. Remembering that in the Atlantic we are talking to radio operators rather than actual air traffic controllers. So whatever we say over a radio must be done very clearly and to precisely the right format. They will understand that, they will relay that by data link to the air traffic controllers at their center, who will respond, and the radio controller will then relay any messages to us. When we're planning a route like this, we don't just look at the weather and assume that because we have fully automatic landing systems in this aircraft, we can land in the worst of weathers. We are actually told the minimum weather we can accept at the planning stage. And those diversions we're using today, Shannon, Keflavik and St John's, have been checked to ensure that during the time we forecast to be in their area, their weather is well above minima and above laid down limits. And we have all the various airfields we might use. We've actually dictated the procedures that Norman and I are following today, and it very clearly defines our own actions through the various parts of the Atlantic crossing. Because the Americans insist on doing things slightly differently, we carry a decoding chart for their weather broadcasts. They are subtly different to the European broadcasts. And then we go on to various profiles for our airline. The one I'd like to show you, because all of these are various operations of the aircraft, standard operating procedures. But the particularly interesting one that we have is the one I was earlier referring to, the actual loss of an engine when on a North Atlantic track. We've got to be jolly careful. We're going to start descending. We've got to be careful for traffic all around us. So the first thing we need to do is actually turn away from the center line of the track. It's therefore important we know where our diversion is, because we certainly don't want to be turning away from it. We want to be, if possible, turning towards it. We want to move away from the center line of the track, keep descending, and not until we're below the lowest level of the tracks can we actually start turning towards our diversion positively. There are a lot of actions for the two of us to complete, added to which we've got to fly the aeroplane, we've got to balance the aeroplane, remembering that we've only got thrust on one engine. We've got to try and talk to aircraft around us so they can be aware of what we're doing. We must try and contact, if we can, air traffic control. But that can be easier said than done. But nevertheless, There is a procedure, we have it on us. If in the worst situation this should happen to us, we can get this out, we can use it and make sure that everything we do is as precise and accurate as it possibly can be, so that in the event of emergency we make our diversion as quickly and as efficiently as possible. It's quite a good procedure. It's one we practice in the simulator, and it really means that the two pilots have really got to work together to make it look good, to feel good, and do a particularly good job. So there we are. That's how we do it in leisure. It's a fascinating subject, the subject of flying these aircraft across these long expanses. And don't think Etops only refers, say, to the oceans. It also can refer to, for instance, flying down through Africa at night, because by night a lot of the airfields in Africa close down, and therefore you need to use these procedures to actually affect that sort of route as well. Obviously, it is much more common to think of it the Atlantic crossing, Pacific crossing. I said earlier, as a final note, we are cleared at the moment to 1:38 minutes from a suitable airfield. This aeroplane, in fact, is cleared finally to 180 minutes, 3 hours from a diversion. That's interesting. Why was that developed? It was actually developed by the Americans to get from the west coast of America to Hawaii, where the journey itself is, give or take, 6 hours. So they needed to be able to get the twin-engine aeroplane a clearance to be some 3 hours from a diversion field. We don't need it for the actual operations we do. Nevertheless, we are hoping in the next few months that we will actually attain that clearance, and we will then become a full 180-minute operator on the Etops scheme of things. So there we are. We've looked at the aeroplane, we've looked at the Atlantic, and we've paid a little bit of attention for you to these Etops procedures. You will find, I'm sure, if you listen to people who've been flying the jumbo jet for many years, they will say to you they fly a 4-engine aircraft only because there isn't a 5-engine aircraft built. It's a reasonable comment. All I can say to you that we, the aircraft, and all these scheme of things has made this sort of flying as safe as it possibly can be. And one very interesting statistic is that today there are more twin-engine aircraft crossing the Atlantic every day than multi-engine aeroplane. And I think that indicates the state of operations in this day and age with this type of aeroplane. During the flight, Norman and I have tried to describe to you the various systems on this aeroplane. Very aware that they're systems that are common to many other aeroplanes, and maybe you've come across them at other times, but we do have on board a new system which I would like to try and describe to you. It's going to be difficult. It's called TCAS. The most difficult part is trying to remember what TCAS stands for. It actually stands for Traffic Alert and Collision Avoidance System. What we're attempting to do with this bit of kit is to actually give the pilots in the air an indication of where other traffic is. There are certain areas of the world where the air traffic system does not give the sort of coverage that we're used to in Europe and in the United States. Long, clear expanses of water, for example. And it's just such an advantage if we can have some sort of indication of traffic in our vicinity. The TCAS system works with the transponder, this being the transponder control box. And the way that you can tell that the TCAS is added to the system is by two additional positions on the mode control knob. TA only, TA/RA. TA standing for Traffic Advisory, RA Resolution Advisory. So, our transponder is now talking to and responding to the transponder of another aircraft in our vicinity. And this information is translated by the TCAS system into symbols that we can see on our HSI. The symbols change according to the position of the aircraft to us. Initially, it is a symbol just indicating that there is traffic there, and then the symbol will change if the TCAS system thinks that that target is in any way menacing to us. What I'd like to do now, because obviously we can't set up this sort of situation in the air, is actually show you the symbols that we could see from our own operations manual. Okay, to show you the symbols then. The first symbol is a white diamond, just outlined like this, which indicates there's traffic in our vicinity, but it's not menacing, it is really for information. If that traffic gets closer, that is to say within 6 miles and at a height difference of 1,200 feet or less, the diamond remains white but becomes filled in. The next stage is, of course, that the computer then says, hang on, this traffic is becoming menacing, we've got to be careful. We then get a filled in circle, amber in colour, and also we get an audio traffic warning. And that means that the computers are beginning to be concerned, we should be concerned about the situation, and consider at this stage avoiding this traffic. So the final stage is the symbol will change to a square, red in colour, and now the computers will actually give us information on how to manoeuvre to avoid this traffic. We do this by either climbing or descending, and continually updates us audibly on our progress, and once the collision risk has passed, it will then clear us to return to our previous flight level. Obviously, in the air, I don't want to, you wouldn't want me to set up this sort of situation. And really it's a shame that we can't, and I hope that that will just give you a little bit of an idea of how the system works. What I can do, however, finally, is just show you our present situation as we are flying along the east coast of America. So if we look at the HSI now, the first thing to point out, if I may, is the symbol TFC, standing for traffic, which means that our TCAS system is online. And then if I can, just point out 2 symbols to you. These are aircraft in our vicinity. That range ring is 20 miles. This aircraft is actually indicating at a similar level. This one is indicating 1,900 feet. It'd actually be 2,000 feet above us. The first aircraft we've actually been following for some time. We're on a very, very similar track. In fact, all 3 of us are now following an East Coast track. They'll either come down south to Florida, or more likely they'll start descending fairly soon into the Boston or New York area. So, in conclusion, I hope that gives you some idea of what TCAS can do for us. Obviously, it's the first time that we in the flight deck have actually had information about other aircraft. One of the great concerns has been in its development with TCAS is the fact that pilots might see a collision situation appearing, take action which would severely embarrass air traffic control. This certainly in Europe has been a major worry. The Americans, while obviously aware of it, have felt that the benefits of TCAS have made it worthwhile to bring it into service quite quickly. So at this time it is now mandatory that all the aircraft flying in American airspace have this equipment. Of course, TCAS is only as good as the number of aircraft that carry it, and I don't think it'll be very long before Europe follows suit and makes the carrying of this equipment mandatory also. We've then got to hope that private aircraft, military aircraft indeed, all follow and carry TCAS, and that certainly, I think, would make for a significant improvement in flight safety in the future. Okay, Norman, we've got, what, just over an hour and a quarter to landing, so let's get the briefing set up.
Okay.
Okay, we'll be looking first at the arrival, which is plate Hotel 3, 17th of May 1993. And the thing in America to particularly remember is transition altitude 18,000 feet.
Roger.
So we'll be commencing the approach procedure from Ormond Beach, and if you'll follow me through on the screen where the approach is all put into the computer. From Ormond Beach, proceeding south through Lama,
Check.
pass through Lama at 12,000 feet, 250 knots.
Yep.
Continuing south through Jessup onto Cosmo,
Yes.
because we anticipate landing runway 18. Want to be at 6,000 feet there,
Roger.
and down to Bitho. From Bitho, which is the end of the arrival route, we'll swing across to Naval, the commencement of the ILS route,
Roger.
inbound 182 degrees,
Check.
coming through Hami to Tuffey
Yes.
on the glide slope at 2,170 feet.
Check.
After Tuffey, continue on a 3-degree glide slope to a decision height of 295 feet.
Check.
In the event of a missed approach, it's a climb to 500 feet, turning right towards Kissimmee and climbing to 2,000 feet to take up the hold.
Okay.
Subject to the approach being successful and landing on 18 right, taxi pattern, you've been to Orlando many times, mean to clear to the left, cross 18 left, 36 right runway,
Yep.
to take either the Bravo or Charlie taxiway into airside 1.
Check. Okay.
And we'll establish our actual parking stand a little later. Okay.
Understood.
As far as the approach is concerned, the absolutely standard procedures throughout, obviously modified track as necessary by air traffic control. The weather forecast is reasonable, possibility of the odd thunderstorm around. Obviously, if there's one in our track, we'll ask for avoidance, and we'll certainly think twice about approaching Orlando if there's one over the field at the time of our arrival. But plenty of fuel on board, we can certainly hold off for some time. The actual final approach, obviously we'll have the ILS on, I'll monitor that, but I'll fly the aircraft manually for a manual landing.
Okay.
For the approach, the speeds that we'll use, our reference speed is 136, so double bug is 136, next bug 176, and the final bug 216.
Check.
Altimeter bug set to decision height 295.
Okay.
Navigational setup, left VOR is set manually on Ormond Beach 112.6 and the course 176, which is the arrival route.
Okay.
ILS set course 182 degrees, frequency 111.9. Both ADFs set on Kissimmee 329.0 in the event of a go-around.
Check.
So that completes the briefing. Norman, any questions?
None at all understood.
Okay, let's have the descent checklist, please.
Okay, descent checklist. Air conditioning, pressurization,
Set.
auto brakes,
Set.
altimeter and IAS modes.
Set and cross-checked.
Briefing.
Was completed. QNH established.
Descent checklist complete.
We've just got a few miles to run to our descent point. We'll actually commence the descent now so that the engines have the opportunity to come back nice and gently. So, descending now, Norman.
Okay.
It's executed.
N1 VNAV speed.
That's checked. quite quiet today. Normally by this stage of approach we would start to see our TCAS indicating a lot of traffic, but today it's quite quiet on the approach.
Approaching 1,000 to level.
Checked. Okay, there's 12,000.
Speed out. Hold.
Checked. And speed's correct as well.
Leisure 705 Heavy, descend and maintain 6,000.
Descend maintain 6,000, Leisure 705 Heavy.
6,000.
Idle Vena. Path.
Good.
Throttle hold.
Checked.
Okay, 10,000 checks.
Thank you.
Radar, good afternoon, Leisure 705 Heavy, 6,000 feet, radar heading 250.
Leisure 705 Heavy, Orlando approach, Roger 6,000, expect lower in 2 miles.
Leisure 705 Heavy, and requesting 18 right.
Leisure 705 Heavy, okay, I can offer you 18 left if you'd like that.
Yeah.
Okay, we'll take 18 left, Leisure 705 Heavy, thank you.
Leisure 705 Heavy, descend and maintain 3,000, fly heading 230, expect a visual approach to 18 left.
Okay, down to 3,000, heading 230 for a visual approach, 18 left, Leisure 705 Heavy.
3,000, 230, flight level change speed.
Thank you.
I'll give you the runway in the box.
Yes,
or...
please. Okay, slight modification to our briefing. We've been given 18 left. It's good and visual. Just turn it on. That's checked. And we'll just fly visually down to runway 18 left. I've got the executive field and I've got the international airfield off to the left also. If you'd like to give me flaps 1, please.
Speed checks, flaps 1. Now let's give you... I'll give you the intercept to the radial
That's
leg.
excellent, thank you.
There we go. And it's
That's fine. Thank you.
8, 2, there we go. There we go.
Okay, I've rechecked the centre and left ILSs.
Okay.
And flaps 5, please.
Speed checks, flaps 5. Okay, just confirm that's 18 left, the runway.
Confirmed 18 left. So approach checks, please, Norm.
Approach check.
Leisure 705 Heavy, clear direct to Orlando VOR, report the field in sight.
Correct to the Orlando VOR, we will call you the field inside, Leisure 705 Heavy.
Okay, briefing,
Reviewed.
altimeters,
QNH is 1017 set and cross-checked.
approach aids,
Checked and set
and recall.
is checked.
Approach checklist complete.
Thank you. And I have the field in sight.
Okay.
Leisure 705 Heavy, we have the runway inside.
Leisure 705 Heavy, thank you. Maintain 3,000, I'll have the approach clearance for you in 2 miles.
Okay, maintain 3,000, Leisure 705.
Okay,
800 to level off.
That's excellent, thank you. Just turning towards the VOR, which is on the executive field. And I've identified positively 18 left. The
Check.
2 main runways. Okay, gear down please.
Gear down.
Flaps to 20.
Speed checks, flap 20.
Good afternoon, Leisure 705 Heavy is with you, visual 18 left.
Leisure 705 Heavy, Orlando Tower, the wind is 1105, runway 18 left, clear to land.
Clear to land 18 left, Leisure 705 Heavy.
Okay, 2500.
Check.
2500.
That's checked and recommence descent as we pass south of the executive view.
Check.
So, taking the autopilot out,
Roger.
flight manually. Flaps 30 please.
Speed checks, flap 30.
And our south,
41.
please.
2500.
And recommencing. Flight director coming off.
Check.
We're on the non-ILS runway. Checked. 2000 set please.
Is set.
Thank you. Landing checklist please.
And the landing checklist. List approach altitude,
Set.
cabin,
Secure.
speed brake,
Armed.
landing gear,
Down. Green.
flaps.
30 flap.
Landing checklist is complete. Clear land, 18 left. Knots from the left at the moment.
That's seen. Thank you.
Fifty, 40, 30, 20, 10.
10.
Speed brake,
Thank you.
2 reverses, 93%.
Thank you.
Knots.
Okay.
Manual braking,
Check.
60 knots.
Thank you. Okay, brakes on.
Roger.
It's good. AP is running.
Yep.
On off. Trucks are confirmed in.
Okay.
One generator's good. Other one off. Good. Okay. That's good. There you go. Shutdown checklist, please.
Shutdown checklist. Fuel control.
Cut off.
IRS.
Off.
Hydraulic system.
Set.
Fuel system.
Off.
Seat belts.
Off.
Flaps.
Up.
Speed brake.
Down.
And park brake.
It's set.
Shutdown checklist.
Thank you. Well, here we are in Orlando, and you can tell that by the lack of jackets. It's certainly different weather to that we left behind in Gatwick. Behind us, the aircraft has been cleaned, refueled, new crew on board, a new set of passengers, and she's now moving backwards for her flight back to the UK. I understand it's going to take them about 8.25 hours overnight, and so that really completes the program we set off to show you. The aircraft, as we said earlier, we're very proud of, we enjoy operating. We've certainly tried to show you everything we could during the program. It's quite difficult because it was a live program, we filmed it as the flight went on, and obviously we can't predict at any stage what will happen at any time. We hope you've learned a little from it. More importantly, hope you've enjoyed it. It's not a one-man band flying an aircraft. There's a lot of help comes from people on the ground and to my crew. Norman in particular, been a great asset as you've seen, helped us through across the Atlantic and down here to Florida, and the cabin crew who've looked after those 327 passengers. And finally, thank you for joining us. We hope you've enjoyed it.